Big Bang. Have you ever thought, monkey, that everything, absolutely everything, started from nothing? Before the Big Bang, there were no stars, no planets, no humans, no monkeys, and no bananas. The thing we call the universe was a vast nothingness. But the strange thing is that nothingness was actually everything. Monkey's head is spinning, but Monkey knows. Simply with a banana, he will understand the formation of the universe, the Big Bang. And Monkey asks, such a vast universe, how could it not have existed before? If there was nothing before, where was everything now? These questions lead Monkey to the birth of the universe, to that first moment, that strange moment when nothing existed yet, but everything was hidden within it. Monkey closes his eyes. What does nothingness look like? No banana, no forest, not even emptiness. There is only one thing there, the essence of everything, a tiny banana seed. This banana seed is not ordinary. It is much smaller than other banana seeds. It is so small that Monkey can barely see it. But within that tiny banana seed lies all the bananas in the universe, even the universe itself. And so, 13.8 billion years ago, this tiny banana seed suddenly explodes. But this is not an explosion like a bomb, Monkey. This is an expansion. The universe suddenly begins to expand in all directions. At that very moment, time begins, space begins, light begins, everything begins. Monkey gets excited. Banana begins. This universal expansion process is called the Big Bang. Monkey asks, what exploded? According to some theories, what exploded was a black hole. And according to this theory, we are in a universe within another universe. In fact, every black hole in our universe is another universe. I will explain the details of this incredible and impressive theory towards the end of the video, Monkey. Monkey is impatient. Tell me, Big Bang. Immediately after this explosion, the universe is hot, very hot, but there isn't even a banana molecule in sight yet. In a time so short that it's 1/1,000,000,000th of a second after the first moment, the universe, which was as small as a banana seed, grows to the size of a banana. In the first few seconds, there were no luminous bananas, no atoms, and no light in the universe. Monkey. Only energy, chaos, and banana-flavored particles. And what happened in those first few seconds? 10 to the negative 43rd seconds. Planck time. The universe was so small that the laws of physics stopped dancing here and lay down. 10 to the negative 35th power seconds. The universe expands at an immense speed in what we call cosmic inflation. The universe is not producing molecules, but probabilities. 10 to the minus 6 seconds. Some banana particles have now formed, quarks, gluons, leptons. But these banana particles cannot become bananas on their own. They must come together to form small bananas. Monkey was excited by this information. Monkey knew he would learn even more fascinating things about the Big Bang. Monkey wrote down the topic he wanted to see in the future in the comments. Tell me, Big Bang, tell me. As time progresses, the universe begins to cool down a bit. Monkey applauds. The first seeds, the first little bananas, but it's still very hot. So hot that light cannot spread, because photons cannot move freely. They bounce off everything. The universe is still opaque. But be patient, Monkey. Soon light will appear, and bananas will appear. Monkey grows impatient. When? Tell me. 380,000 years later, Monkey, the universe finally cools a bit. Protons and electrons no longer repel each other so fiercely. They come together. And from this coming together, something is born, the atom. The first hydrogen atoms form. The universe sighs in relief. When atoms form, photons can now move freely in the universe. They spread throughout space. And this is a magical moment. For the first time, something visible has formed in the universe. Light. And you know what, Monkey? That light, the first visible thing in our universe, is still with us. It is still visible. And we call this light the cosmic microwave background radiation, CMB. Monkey was very curious about the first light. Monkey pointed a radar at space. Monkey received a signal. Buzzed. The signal of the first light left over from the Big Bang. Monkey was very surprised. Is this a baby photo of the universe? Exactly, Monkey. We can call it the universe's first selfie. Since then, this light has continued on its journey, and scientists like us are finding traces of the past by observing this light. And you will learn all about those traces today, Monkey. Yes, yes, with bananas. Monkey was very excited. Tell me, there is now light in the universe. But something is missing, Monkey. Light-emitting bananas? There is light, but there is no light source. Because atoms have formed, but they have not yet combined to form light bananas. And as the universe continues to expand, gravity comes into play. This invisible gravity brings hydrogen atoms together. As they gather, they compress. As they compress, they heat up. Monkey worries. His eyes widen. Will it explode? No, Monkey. Here, the first nuclear fusion begins. Atoms fuse together, releasing energy, and finally it forms the first glowing banana. At that moment, something changes. Darkness gives way to light. The dark age that lasted for millions of years is now coming to an end. Later, some of these luminous bananas come together to form groups of luminous bananas. We call these groups galaxies. Wow. Monkey was already deeply fascinated by the formation of the universe. Monkey wanted to express gratitude. He liked the video. He left a banana in the comments. You're welcome, Monkey. You'll be even more fascinated. Let's continue. Throughout the universe, hundreds of billions of galaxies form. Each one contains hundreds of billions of luminous bananas and massive spherical bananas beginning to orbit around them. Monkey was amazed once again. These luminous bananas, these galaxies, did they all come from that tiny banana seed? Yes, Monkey, and they're still expanding. Still expanding? Monkey was surprised. Monkey sets up his telescope. Monkey looks up at the sky. Monkey focuses on a galaxy. Monkey notices that the galaxy is slowly moving away. It's like it's running away. It's not running away, Monkey. It's the natural expansion of the universe. While galaxies remain stationary, the space between them expands. And we call this the cosmic expansion. Monkey asks, how do we know? Light is also a wave, Monkey. And waves become longer as they are stretched. If light from a galaxy is stretching, its color shifts toward red. This is called redshift. Monkey looks through the telescope, analyzes the light. Red light. All red. They're moving away. Yes, Monkey, scientists just like you discovered that the universe is still expanding by observing this red shift. But it doesn't stop there, Monkey, because it's not just expanding, it's accelerating. Science calls this force dark energy, a mysterious, invisible energy that pushes space. It makes up 70% of the universe. What's even more interesting than dark energy, Monkey, is the theory that the universe was created by the explosion of a black hole, and that every black hole contains a universe. At the heart of black holes lies a place called a singularity, infinite density, near zero volume, a region where the laws of physics break down and the Big Bang began with a singularity. The entire universe was compressed into a single point. Time itself had stopped there. Monkey was thrilled. Tell me, some physicists say a black hole is where time flows inward. The Big Bang is the moment when time flows outward. Think about it. In a black hole, everything collapses and shrinks. In the Big Bang, everything is expanding, growing. Both bend space-time. Both begin with infinite density, but with one difference. A black hole pulls you in, the Big Bang pushes you out. And according to some scientists, Monkey, every black hole could give birth to a new universe. So a black hole formed in another universe could be the beginning of our universe. Do you think this is possible, or have these scientists lost their minds? I'm waiting for your answer.